So today we are going to solve systems of linear inequalities, and we're going to start out. This is basically more or less a graphing exercise, and how good you are at graphing and getting lines that are not in slope-intercept form into slope-intercept form, or graphing using intercepts. You can use either one when you're graphing them. And then we do have some applications of systems of inequalities where we're going to show, instead of what one answer could be a possibility, what are all the possible answers that there are. And then we're going to look at if I graph more than two lines, 3 or 4 of them, that we're going to actually create a shape, and then you identify the shape. So hopefully you know what a square is, what a rectangle is, a parallelogram, a quadrilateral, or a trapezoid. All right, all of those. All right. So a system of linear inequalities is a set of 2 or more linear inequalities with the same variables. So the solution is an infinite set of points. All right. So when we graph these, all right, and we're going to shade them, and actually I'm going to pause this just for a second. Using colored crayons or colored pencils or crayons actually will make finding the answer and solidifying the answer here easier, because instead of trying to shade 2 different ways with your pencil, if we do it with 2 different colors, then because our answer is going to be the intersection of 2 shaded regions. And by using crayons to do that, if you're interested, all right, then that will help you to shade one color and shade the other one another color, and then where the 2 shadings come together is where our solution is, and then we can really define that answer. All right. So go ahead and graph these 2 lines on your graph paper. Reminder: the first one says less than, so that's going to be dotted. The second one is greater than or equal to, so that's going to be solid. So graph those 2 lines, and then we will look at the shading of them. So first of all, just do the graphing of them, and then we'll do the shading of them together then. Okay, so now we have the lines graphed. To do the shading, so I'll use crayons too. So we've got the purple line here, which is y equals negative, y is greater than or equal to negative x plus 2. Now we know when it says greater than or equal to, that means it's above the line. So we're shading this area here. All right, is the one color. All right, above it. And so that one's in purple. And the other line is in blue, and that says less than. All right, so that means we're going to shade below that one. So that means we've got down here. All right, and then our answer is going to be the area where they are both shaded. So our area is the section to the right. And so when you can use the crayons to do it. If you don't want to use them, you don't have to, but some people find it easier then, so then I can figure out exactly where my answer is at, and that would be this area here where we have the purple and the blue together. So the answer to this system is an infinite number of solutions that are all in this region over here to the right of the graph. So we've got the 4 regions. We have the top, the bottom, the left, and the right. So in this case, it's the area to the right. Okay, so get another one. So go ahead and do this one. You guys do this one. So graph the lines and do your shading, and then we'll check it. All right, so this is key to this is, making sure you have the right line, dotted or solid, and then making sure that you're in the correct area. Now, how could I check my answer in this case? We pick a point and see if it works. So we could pick our favorite point in this case. We could pick the point 0, 0, All right, see if it works. All right. So is 0 less than negative 3 times 0 plus 2? All right, so is 0 less than 2? All right, that's a true statement. All right, so it works for the dotted line. All right, it's below there. All right. So then is 0 greater than or equal to negative 1? All right, yes, that's true. So that means it worked there. So I know that any point in this region is a solution to the solution to the system then. All right. Okay, so let's look at a word problem then that involves systems of inequalities. Lauren wants to paint no more than 70 plates for the art show. It costs her at least $50 plus $2 per item to produce red plates and $3 per item to produce gold plates. She wants to spend no more than $215. Write and graph a system of inequalities that can be used to determine the number of each plate that Lauren can make. All right. So first of all, we've got to look at, okay, what's going to be X, what's going to be Y. All right. So we're going to let X represent the number of red plates and Y represent the number of gold plates. All right. So we'll start there. You got to have, what do X and Y relate to? So X is the red plates and Y is the gold plates. All right, and so it says we want no more than 70. Okay, well, what does it mean to have no more than something? What inequality symbol do I use for that? Billy. Less than or equal to. So we'll say that X plus Y must be less than or equal to 70. All right. The number of red plates plus the number of gold plates must be less than or equal to 70. All right. So the first part just involves the quantity of them. We talked about this the other day, same type of thing. All right. Then our second situation then, the other part is going to be the amount of money that is involved. All right. Did it cost her at least $50? So she starts with $50 plus $2 per red plate and $3 per gold plate. All right. But she doesn't want to spend more than $215. So we have to put all those money values together then. All right. So we start out, we've got the $50. All right. This is a set cost that she has to pay. Maybe it's a setup fee. Maybe it's to compensate the people that are working for her. One of those two things. All right. So she's got that amount of money that she's got to spend. Plus she spends $2 for every red plate. All right. So $2 for every X and $3 for every Y, because the gold plates are $3. And she doesn't want to spend more than $215. So we have the same situation there, less than or equal to 215. Okay. So when you're dealing with these equations for these systems with the word problems, almost always the first one is going to involve just the set number that you're working with. Okay? That, hey, it's 70 plates, all right? So the X plus Y is 70. All right, or in this case, less than or equal to. All right, and then we involve money or weight or something else like that, or a percentage like we did the other day. We talked about the percent of protein there was, those type of things. Right? So now we're going to graph these two systems, or graph this system, so that we can see what are the possible answers for solving this. So let's see here. So we have a couple different options. We can do it by intercepts. Right? If you prefer to do intercepts, in this case, one thing nice about this is that if you have X plus Y equals 70, my intercepts are 70. Okay, the x-intercept is 70, the y-intercept is 70. Okay? So that helps us, makes it easier for us. Okay? And then we can work on the other one. We can do it a couple different ways. We can put numbers in, just find 2 points. We can use the intercepts either way. All right. So let's look at them. So I'm going to go by tens here on my x and y axis. So these are. I'll just change it. All right. So we're going to go to. Oops. Come on. Let's see how fast I can do this. So I'm going to go to 80 on the x and the y. I'm going by tens. I could have left it in the ones, but. All right. So first thing we know, we've got one line is going to be x plus y equals 70. All right. So that's just going to be a solid line from 70 to 70. So there's our first one. All right. So the second one then, we have to do a little bit of work there. So we'll subtract 50 from both sides first. So we get 2x plus 3y less than or equal to 165. Now we could still use intercepts here, all right, if we wanted to. Or we could solve for y and put it in slope-intercept form and do it. Probably the intercepts are going to be a little bit easier in this case. All right. The one thing is that my x window is not quite big enough. All right, so I'm going to have to work on that. All right, got to make it a little bigger. So my x-intercept is going to be 82.5. And my y-intercept, let's see, what's 165 divided by 3? Anybody know? Top of your head, Michael? No? 55, okay. So my y-intercept is 55. All right, so that one goes there. My x-intercept is 82.5. All right, so that's a little bit past my end down here. It's probably close right there. All right, now draw that line. Right, so we can find the intercepts. It's always easier with these, or usually easier with these, just to use your intercepts for graphing them. And then, now, the reason we only have positive and negative, or the positive numbers in this case, is because we don't care about negative red plates or negative gold plates, so it doesn't matter there. And then we're just going to shade. Then we have both sections, or both lines are less than or equal to. So my answer is going to be this area here. Right, because it's the area that's less than or equal to both of them. Right. So that means that any number, any pair in this section then will be a solution to this problem. Now, the question is which one's going to give you the most red and most gold plates, and that would actually be the point where they intersect here. All right, that point where they intersect. This spot here is actually going to be the spot where it gives them the most of both red and gold to be able to solve the solution. All right, so this is red plates here and gold plates here. And don't forget, when you are doing these application ones, you need to make sure you identify your axes, tell what they represent. All right, so in this case, the gold and the red. All right, so I want you to, with this one, let's just start out, and I want you to try to write these inequalities first. All right, and then we'll. All right, so with this problem, we had x plus y less than or equal to 40, 2x plus 2y, 2.5y greater than or equal to 90. So since we're less than, the black line is the less than or equal to 40, and the blue line is the greater than or equal to 90, my possible answers are pretty slim here. All right, you have to remember that. So we label them on the x-axis are the hot dogs, and the y-axis are the sausages. All right, so make sure you label them. All right. So, and then we're going by tens. All right, on mine. Yours may not be, because you may have done 10, 20, 30, 40, 50. Well, I only did ones. So, okay. All right, last one. All right, so here we have a system of more than 2, and then we're going to classify it by what region, the region it's created. All right, so you're going to have, we have 4 different lines here that we're going to draw, so we're probably going to have a 4-sided figure. So it might be a square, might be a parallelogram, could be a rectangle, could be a some other type of quadrilateral, could be a trapezoid. Okay, now you guys all know what a trapezoid is, right? Trapezoid just has one pair of parallel sides. All right. So we're going to do all 4 of them, and then we will figure out what that region is when we're done. All right, so I'm actually going to draw this with 4 different colored lines. So we'll start with this fun green, all right? So x is greater than or equal to -2. What kind of a line is that? Horizontal or vertical? Okay, all the x equals are vertical. So x equals -2 is a vertical line. All right. X is less than or equal to 3. We're going to do that in purple. That's a vertical line. All right, y is less than or equal to -x plus 1. We'll go ahead and do that one as blue. So that has a y-intercept of 1 and a slope of -1. All right, and then y is less than or equal to 4. We'll make that red. That's horizontal. All right. So in this case, we could color with 4 different colors also and see where they intersect. I'm going to do this just a little bit different than that, though. All right, so my green, it says greater than or equal to -2, so that's this area here. All right. Purple, that's less than or equal to 3, so that's this area here. So we're talking about the area between those 2 lines. All right, okay, we had a pretty good idea of that anyways, because the greater than the one, less than the other one. It says greater than or equal to the blue, so that's going to be up here. All right, and less than or equal to the red. All right, so we got to find out where all those colors are and put them together. So we're talking about this area here. All right. It gets a little bit trickier, making sure you've got the right area there. So it's a good idea to emphasize that with one color, just to make sure. All right, you can see that one there. All right, so what is that thing? All right, it's a four-sided figure. All right, not a square, not a rectangle, not a parallelogram, but I have two parallel or one pair of parallel sides. From x equals -2 to x equals +3. So that means this is a trapezoid. Right? So you just got to identify them. Once you get them drawn and shaded, what is that thing? In this case, it's a trapezoid.